Hey champs of Examsnet, welcome to the question series of Examsnet. Students, you must have explored our website www.examsnet.com. This site is a great place for you to practice your entrance exam question papers because here you will find so many entrance exam question papers along with their detailed PDF solutions. And you must download our app. The link is available in the description box for better preparation of your exam. So today students, we will be solving JEE 2024 31st Jan shift first question paper. In this particular video, I will be solving physics part of the paper. So here we go. The first question of this series is question number 31. The parameter that remains the same for molecules of all gases at a given temperature is. So this question is from the chapter of kinetic theory of gases. So the question is asking that at all the gases and at a given temperature, which of the following will remain the same? Okay. So the first one is kinetic energy. Since we know that kinetic energy for any gas is equals to F by 2 into kBT and N by 2 kBT, na? So F by 2 kBT. But if it is asking for all the gases, mean the gas could be monoatomic or it may be diatomic or it may be triatomic. So for monatomic, F is equals to 3. For diatomic, F is equals to 5, and for triatomic, F is equals to 6. So in all these three cases, the kinetic energy will not remain same. So this is not the correct option, okay? Now, second one is momentum. According to me, momentum is the correct answer, as since the momentum P, it its value is 0 for the gases, because the in gases the molecules moves in random direction, and since momentum is a vector quantity, so if we take the average of all the displacement or uh, the movement done by the gases, so according to me, as an average, the momentum value always comes out to be 0. So according to me, the momentum remains constant, and the mass will also not remain constant, since it is if the gas is monatomic, diatomic or triatomic, so these three gases will have different masses. So different masses means this will not remain same. And speed also not remain same, since we know that there are different types of speed. Like we take the average value, which is equals to 8 kbt by pi m. We take RMS value, which is equals to under root 3 kbt by m. We take sometimes most probable value, its value is 2 kbt by m. So these three speeds have different values, so speed cannot be the correct option. So among these four options, momentum is the correct answer, okay, which remains same. Now next question, question 32. Identify the logic operation performed by the given circuit. So this question is from the chapter of electronic devices. In this circuit, this is a NOT gate, this is also a NOT gate, and this is a NAND gate. Now this is NOT gate, so here we will get A bar. This is a NOT gate, here will get B bar. This is NAND gate, means at Y we will get A bar dot B bar whole bar. Okay, so using De Morgan's law, according to De Morgan's law, Y will be equals to A bar bar dot plus B bar bar. So it will be equals to A plus B. So our output Y will be A plus B. Okay. So A plus B is what? OR gate. Okay. So the correct option is C. Now next question 33. The relation between time t and the distance x is t equals to alpha x square plus beta x, where alpha and beta are constant. We have to find the relation between acceleration and velocity. Okay, so this question is from the chapter of kinematics. We are given the time t as alpha x square plus beta x. Okay, now at first differentiate this equation with respect to time. Okay, when we differentiate it with respect to time, we get 1 is equals to 2 alpha x into dx over dt plus beta into dx over dt, and dx over dt is what? Velocity. Okay, so we get 1 equals to 2 alpha x into v plus beta into v. Okay, now again differentiating this equation 1 with respect to time, we get 0 equals to 2 alpha. Now differentiating with respect to parts, first into differentiation of second plus second into differentiation of first. Okay, plus beta into del v over del t. Now this del v over del t is nothing but acceleration. Okay, so now we get 0 equals to 2 alpha x a plus v dx over dt is what? Velocity v plus beta into a. So we get 0 equals to 2 alpha x a plus 2 alpha v square plus beta a. Now from equation, this is equation second. From equation 1, find the value of 2 alpha x. So from equation 1, 2 alpha x v is equals to 1 minus beta v. So 2 alpha x equals to 1 minus beta v over v. Okay. Now putting value of 2 alpha x from equation 3 in equation second, so we get 0 equals to 1 minus beta v over v into a plus 2 alpha v square plus beta a. Now solving it, we get 1 minus beta v into a plus 2 alpha v cube plus beta av equals to 0. Now we get a minus beta av plus 2 alpha v cube plus beta av equals to 0. This cancels out. So we get a is equals to minus of 2 alpha v cube. So this is our final relation. A is equals to minus 2 alpha v cube. So the correct answer is option A. Okay. Now next question. 34. The refractive index of a prism with apex angle A is called A by 2. The angle of minimum deviation is. So student, this question is from the chapter of optics, and this question is very important since this question has been asked in year 2023. Along with it, it has been asked in on the 27th or 28th of this Jan 2024 paper. Okay, so this is very important. Now, according to this, we have to find the angle of minimum deviation. We know that the mu refractive index is equals to sine A plus delta m. This is the common formula, okay? Sine A by 2. And this mu is what? Cos A by 2 over sine. This is the direct formula. Huh? So you should learn this formula. Cos A by 2 upon sine A by 2 into sine A plus del m by 2 over sine A by 2. This sine A by 2, this sine A by 2 cancels. So we get cos A by 2 is equals to sine A plus delta m by 2. Now we can write cos a by 2 as sine pi by 2 minus a by 2, okay, equals to sine a plus delta m by 2. How we write this? Since let us say these are four quadrant. In first quadrant, all are positive. In first quadrant, all are positive. In second quadrant, sine and cos are positive. In third quadrant, tan and cot are positive. In fourth quadrant, sec and cosec are positive. Okay, so this is 0. This is pi by 2. This is pi. This is 3 pi by 2. Now we are writing cos a by 2 as sine pi by 2 minus a by 2 means when this quadrant we are dealing with the quadrant 1 means sine pi by 2 minus something minus theta, and in first quadrant all the parameters are all the trigonometric functions are positive. So when we subtract sine 90 minus theta, so at that time we get positive theta means this. Okay, so sine pi by 2 minus a by 2 equals to sine a plus del m by 2. Sine cancels, so we get pi by 2 minus a by 2 equals to a plus delta m by 2. So we get delta m equals to what? Pi minus 2a, solving it. So our correct answer is delta m. Deviation angle is what? 180 degree minus 2a. So the correct option is option D. Now next question 35. A rigid wire consists of a semicircular portion of radius r and two straight sections. The wire is partially immersed in a perpendicular magnetic field B equals to B naught J. As shown in figure, the magnetic force on the wire if it has a current I is. Since this question is from the chapter of magnetic effects of current and magnetism, okay? Now, according to this, we have to find the magnetic force on the wire. In this, the current is in upper direction, and in this, the current is in downward direction. So, the force due to this wire having current in upward direction and this straight wire having current in downward direction will cancels out each other, okay? Now we have to find the force due to this curved surface only. So for this curved surface, let us say the current is flowing like this in this direction, okay? So force F will be I L cross B. This is the direct formula to find the force. Now, if we see the options, in options, the net force is direction is given as what? J, 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 J. Okay. And in our question, the magnetic field is also along the J direction. So, if the magnetic field is along J direction, so the options are wrong according to it. Since F is equals to what? I L cross B. So how it could be possible that magnetic field and force both are in same direction? It cannot be possible. So according to me, the magnetic field B must be in K direction, means Z direction. Okay. So if we see the axis, okay, this is I, this is J, this is K. If the magnetic field is in K direction, and the current is flowing in I direction, then at that time the force will be in minus of J direction. Since L cross B means L is what? I cross K. I cross K means minus of J. Okay. And if we use FBI, FBI rule. So according to FBI rule, if the magnetic field is in k direction, current is sorry if the force in is k direction, current is in I direction, so magnetic field will be in the negative downward negative j direction. FBI rule is what? If magnetic field is in this direction, current is in that direction, so force will be in this direction. So according to me, this in this question the magnetic field is not in j direction, it will be in k direction. Okay, so using it we get the answer F equals to I L cross B. I L is length is given as what? This length is given as consists of a radius r and two straight sections. Okay, so it will be equals to L cross B. L is in I direction, B is in J direct, sorry, B is in K direction according to me. So it will be equals to, and L is 2R. Okay, this L is what? 2R. So we write I 2R iota cap cross B into K cap. So force will be equals to 2I R B and minus of J cap. So the correct answer is option D. Option D is the correct answer. Only when we will take magnetic field B in K direction, okay, not in J direction. Now next question. If the wavelength of the first member of Lyman series of hydrogen is lambda, the wavelength of the second member will be. This question is from the chapter of atomic and nuclei. It is asking about the Lyman series. Means for Lyman, this is Lyman, then Balmer, then Paschen, then bracket, and at last P fund. Okay. So for first member of Lyman series, n equals to 1. The transition is from 2 to 1. And for second member of the Lyman series, the transition is from 3 to 1. So now solving it, we get 1 over lambda equals to 13.6 over HC into Z square 1 over n square. N square means 1 square minus 1 over 2 square. Okay. And this is for first member. For second member, 1 over lambda is equals to 13.6 over HC into Z square. 1 over 1 square minus 1 over 3 square. Now dividing first and second. So we get, let us say this is lambda dash. So we get on dividing 13.6 SC, 13.6 SC cancels, Z square cancels. To 1 over lambda over 1 over lambda dash. It will be equals to 2 to 4 minus 1 over 4 upon 339 minus 1 over 9. Okay. So we get 1 over lambda into lambda dash over 1. It will be equals to 3 by 4 into 9 by 8. So we get lambda dash over lambda. It will be equals to 27/32. This implies that lambda dash equals to 27/32 lambda. So this is our correct answer. So lambda dash will be equals to 27/32 lambda. Now next question 37. Four identical particles of mass are kept at the four corners of a square. If the gravitational force exerted on one of the masses by the other mass is this much, so we have to find the length of the side of the squares. Okay. Now this question is from the chapter of gravitation. Now according to this question, let us say there is a square, okay? There is a square and having four identical masses at each corner. Let us say each having a mass of m. Okay, now this side is of, let us say, A. Okay, now if this is exerting a force in this direction and this mass m is exerting force in this direction, so for these two the force will be equals to gm square over a square, and here also force is equals to gm square over a square. And for this, in this direction, diagonal direction, since the direction is of diagonal is of root 2a, so in this direction f force will be equals to gm square over root 2a square, so it will be equals to gm square over 2a square. So the net force, resultant force will be the resultant of these two, let us say F1 and F2, resultant of F1 and F2 plus this F3 force. Okay. So resultant of these two, F1 and F2, will be equals to root 2 into F plus this F3 force. Okay. So it will be equals to root 2 into gm square over a square plus F3. F3 is what? Gm square over 2a square. So it will be equals to root 2. It will be equals to root 2 if we take gm square over a square common. So we get root 2 plus 1 over 2. Okay. Now, according to the options, if we compare this with the option, the option is what? Root 2 plus 1 over 32 gm square into L square. But our answer is what? Okay, this would be 2 root 2. But our answer is what? 2 root 2 plus 1 over 2 into gm square over a square. Now, if we compare these two, so this 2a square is equals to 32 L square. 2 ones are 2, 1, 3, 2, 6 are 12. It means a square equals to 16 L square. This means a is equals to nothing but 4L. So our correct answer is 4L, option B. Now next question 38. The figure represents two isobaric processes for the same mass of an ideal gas. Okay. Since these are the straight line, means it is representing an isobaric process. And it is said in question also. And this question is from the chapter of thermodynamics. Okay. Now we have to find which one is greater, either P1 or P2. Okay. Since we know that the ideal gas equation PV equals to nRT. So V is equals to nRT over P. Okay. So V is equals to nR over P into T, means this slope is directly proportional to what? 1 over P, na? This slope is directly proportional to 1 over P if the graph is between V and T. V and T, this 1 over P is the slope, means greater the value of P, smaller will be slope, or greater the value of slope, smaller will be P. Here P1 and P2. Here P1 is having less slope. Less slope means P1 value is greater, okay, and P2 is having more slope. More slope means P2 value is small. So P1 is greater than P2. Okay. So the correct option is option D, that is P1 is greater than P2. Now next question 39. If the percentage errors in measuring the length and the diameter of a wire are 0.1% each, the percentage error in measuring its resistance will be. So this question is from the chapter of units and measurement. We have to find the percentage error in the resistance. Okay. Since we know that R equals to rho L over A, where A is the area. Okay. And we are given the percentage, diameter of the wire. Means if area equals to pi r square, so here in place of r we have to write d by 2. Okay. So from this r will be equals to rho L over pi d by 2 whole square. So it will be equals to rho L into 4 over pi into d square. Okay. Now in this relation, 4 is constant, rho is constant, pi is constant. Only the variable quantities are L and D. So using error analysis, delta R over R, it will be equals to delta L over L plus this is a square na, so 2 delta D over D. Now putting the values, since delta L over L is what? 0.1% and delta D over D is also 0.1%. So the percentage error in delta R over R will be 0.1% plus 2 into 0.1%. It will be 0.1 plus 0.2. So it will be equal to 0.3%. So the correct answer is 0.3%. Okay, option B. Now next question. In a plane electromagnetic wave, the electric field oscillates sinusoidally at a frequency of 5 into 10 to the power 10 Hertz and an amplitude of 50 volt per meter. The total average energy density of the electromagnetic field of the wave is. So this question is from the chapter of electromagnetic waves. Okay. Now, since we know that the formula for average density is equals to 1 by 2 epsilon naught E square. Okay. So, average energy density UE will be equals to 1 by 2 and epsilon naught is what? 8.854 into 10 to the power minus 12 into E square. E is given as what? 5 into 10 to the power 10 Hertz. Okay. So 5 into 10 to the power 10 Hertz whole square. So solving it, we get 1.106 into 10 to the power minus 8 joule per meter cube. Okay. Okay, we are given the frequency, na? Sorry, 5 into 10 to the power 10 Hertz is the frequency and amplitude is 50. So here we write into 50 square. 50 square, okay? Into 50 square. So answer will be 1.106 into 10 to the power minus 8 joule per meter cube. So the correct answer is option A. Now the next question is 41. A force is represented by F equals to ax square plus b t raised to the power 1 by 2, where x equals to distance and t is the time. We have to find the dimension of b square by a. So this question is from the chapter of units and measurements. Given F force equals to ax square plus b t 1 by 2. So whatever be the dimension of f will be the dimension of this, and whatever be the dimension of f will be the dimension of this. So f equals to ax square means a equals to f over x square means the dimension of a will be equals to dimension of f over dimension of f is x square, and f will be equals to b t 1 by 2 means b dimension of b equals to dimension of f over dimension of t 1 by 2. Okay, so according to question we have to find the dimension of b square over a. B square over a means b square over a means f square over t over f over x square. Okay, this one f cancels each other, so it will be equals to f x square over t. Now dimension of f is what? M L t minus 2, and dimension of x means length L square over dimension of t is this capital T. So b square over a, it will be equals to m L cube t minus 1. Okay, minus 3. So the dimension of b square over a will be m L cube t minus 3. So the correct option is option A. Okay, now next question 42. Two charges Q and 3Q are separated by a distance r in the air. At a distance x from charge Q, the resultant electric field is 0. We have to find the value of x. So this question is from the chapter of electrostatics. According to this, we have to find the distance of x means the value of x at which the resultant electric field is 0. Okay, let us say this is the diagram. Let there is a charge plus q and this is charge plus 3q. Okay, its distance is these two charges plus q and plus 3q are separated by a distance r. Let us say there is a point P. At this point, the net electric field is 0. Okay, as given in the question, this is the point P where the electric field is 0. Let us say the distance between the charge Q and the point P is x. So the distance between point P and let us say this is A, this is B. So the distance between point B and B is r minus x. Okay, so now since the total net electric field at point P is 0, so the electric field between point A and P will be equal to the electric field between point P and B. Electric field between A and P will be equal to the electric field between P and B. So the electric field between the point A and P will be equals to K Q over R square. R is what here? X. So X square, it will be equals to K into Q. Q is what? 3Q over R square. R is what? R minus X. So R minus X whole square. Okay. Now solving it, K cancels out. Q cancels out. So 1 over X square, it will be equals to 3 over R minus X square. Okay. Now solving it, R minus X square is equals to 3x square. Now opening the bracket, a square plus b square minus 2ab equals to 3x square. So r square minus 2rx will be equals to 3x square minus x square. It will be equals to 2x square. So this rx square minus 2rx equals to 2x square. Okay. Now it will be equals to 2x square minus r square plus 2rx will be equals to 0. When we solve this, we get r minus x equals to root 3x. Okay. So x will be equals to r minus x over root 3. Okay. R minus x over root 3, or we can write it as x is equals to r over root 3 plus 1. Yeah, x is equals to r over root 3 plus 1. This is our final answer. So the correct option is option C, r over 1 plus root 3. Now next question 43. In the given arrangement, a doubly inclined plane, two blocks of masses capital M and small m are placed. The blocks are connected by a light string passing over an ideal pulley as shown in the figure. The coefficient of friction between the surface of the plane and the blocks is 0.25, means mu is given as 0.25, the friction coefficient. The value of small m, for which capital M is 10 kg. Okay. We have to find the value of small m. Okay. The capital M is given as what? 10 kg. So this question is from the chapter of kinematics. Let's solve this as, let us say this, okay, this is of 10 kg na. Let us say the tension force is in this direction, and from here, due to this mass m, tension force is in this direction. Okay, let us say F1 friction is acting in this direction and F2 friction is acting in this direction. This is 53 angle. This is 37 angle. Okay, 37 degree angle. So here in this direction, we will write mg sine theta 1, where theta 1 is 53 degree. And in this direction, we will write mg sine theta 2. Okay. Acceleration in this direction is given as 2 meter per second square, and acceleration in this direction is given as 2 meter per second square. Okay. Now, simply solving it, what we write? The first equation will be mg sine theta 1 minus this mg sine theta 1 minus this tension force minus but mu mg cos theta will be equals to mass into acceleration. So for this, m is given, capital M is 10, gravity is 10 into sine theta 1 means sine 53 degree, and sine 53 degree is what? 4 by 5. So it will be equals to 4 by 5 minus tension T minus mu mg. Mu is given 0.25 into m is 10 into gravity is 10 into cos theta. Cos 53. Cos 53 is 3 by 5. So into 3 by 5, and it is equals to mass into acceleration. Mass is 10, acceleration is 2, means 20. So it means 5 into 2, 10. 4 to the 8 into 10, 80 minus t minus this we can write as 1 by 4. So we write 5 to the 10, and if we write this as 1 by 4, so it will be 2 to the 4. So we write then 2 5s are 10, to 5 3s are 15, minus 15, it will be equals to 20. This is our first equation. Okay. Now for this small mass m, we write the equation as this T minus mg sine theta 2, okay, minus mu mg, this cos theta 2, Okay, it will be equals to mass into acceleration ma. So tension T minus m is, we have to find this m into Gg is gravity 10 into sine theta 2 means sine 37 degree. And sine 37 is given as sine 37 degree is what? 3 by 5 into 3 by 5 minus mu. Mu is given as 0.25 means 1 by 4 into m. We have to find this m into gravity 10 into cos theta means cos 37 degree, and cos 37 degree is 4 by 5 into 4 by 5 equals to mass. We have to find this mass into acceleration is 2. So solving it, we get 5 2s are 10, 5 2s, 5 2s are 10, 4 4 cancels. So we get T minus 6m minus 2m equals to 2. Okay. T minus 3 2s are 6m minus 2 into m minus 2m equals to 2m. Okay. So we get T minus 8m equals to 2m. So it will be T equals to 2m plus 8m means 10m. Okay. Now putting the value of T from equation second into equation 1, so we get 80 minus 10m minus 15 equals to 20. So 80 minus 15, 5, 7 minus 1, 65 minus 10m equals to 20. So 65 minus 20 equals to 10m. 5, 3 equals to 10m. So m will be equals to 45. M will be equals to 4.5. So the correct answer is m equals to 4.5 kg. So the correct option is B. Okay, now next question 44. A coil is placed perpendicular to a magnetic field of 5000 Tesla. When the field is changed to 3000 Tesla in 2 seconds, an induced EMF of 22 volt is produced in the coil. If the diameter of the coil is 0.02 meter, then the number of turns in the coil. Okay, we have to find the number of turns in the coil. Okay, so this question is from the chapter of magnetic effect of current and magnetism. Okay, magnetic effects of current and magnetism. Now we have to find the number of turns. Okay, since we know that the induced EMF E equals to n number of turns into delta phi means magnetic flux over t time, and we know that this delta phi is equals to change in the magnetic field into area. Okay, at first the magnetic field is what? 5000 Tesla, and after that the magnetic field changes to 3000 Tesla means delta B is 2000 Tesla. Okay, 2000 Tesla. And A is the area. Area is what? Pi r square. Okay, and we are given the diameter is 0.02 meter means r will be 0.01 meter. Okay, now using these values, delta phi will become 2000 Tesla into pi r square. Pi into r. R is what? 0.01 whole square. So it will become 2, okay, 2 into 10 to the power 3 into this. So it will become 0.2. 0.2 pi. Delta phi will become 0.2 pi. Now this induced EMF E will be equals to n number of turns into delta phi, that is 0.2 pi over time. T is given what? T is given 2 seconds over 2, and EMF is given as 22 volt. Now using this we get 22 equals to n into 0.2 pi over 2. So this implies that n will be equals to 44 over 0.2 pi. Therefore, n will be equals to 70. So the number of turns will be 70. So the correct option is B. Now next question 45. The fundamental frequency of a closed organ pipe is equals to the first overtone frequency of an open organ pipe. If length of the open pipe is 60 centimeter, the length of the closed pipe will be, we have to find length. So this question is from the chapter of oscillations and waves. Okay. Now according to question, there are two pipes. The first one is closed pipe. Closed pipe means like this. Okay. Its length is given L1. And the second one is open pipe. Open pipe is like this. Its length is given as L2. There is a direct formula for the fundamental frequency of closed pipe and open pipe. For closed pipe, the fundamental frequency F1 is equals to V over 4L1. And for open pipe, the fundamental frequency F2 equals to V over 2L2. Now, according to question, the fundamental frequency of closed organ pipe is equals to first overtone frequency of an open organ pipe. First overtone frequency of open organ pipe means F2 equals to 2 into V over 2L2. First overtone. 2 cancels, so we get V over L2. So from the question, F1 equals to F2 means V over 4L1 equals to V over L2. So from this we get L2 equals to this V cancels 4L1. Okay, 4L1. Now, if the length of the open pipe is 60, length of the open pipe means L2. L2 is 60 equals to 4L1. So we get L1 equals to 15 centimeter. So the length of the open pipe is 15 centimeter. Okay, 15. So the correct option is option D. So the next question is 46. A small steel ball is dropped into a long cylinder containing glycerine. Which one of the following is the correct representation of the velocity time graph for the transit of the ball? So this question is from the chapter of kinematics. Since the question is about the glycerine means the question is for the terminal velocity. Okay. So if we draw a graph between terminal velocity and time, terminal velocity of time. So at first the terminal velocity increases. So if the terminal velocity keeps on increasing, the graph will move like this. And after a certain point, the terminal velocity becomes constant, means the graph will move like this. Okay. So this is the graph for the crystalline between velocity and time. So the perfect answer which matches with it is option B. Okay. Now, next question 47. A coin is placed on a disc. The coefficient of friction between the coin and the disc is mu. If the distance of the coin from the center of the disc is r, the maximum angular velocity which can be given to the disc so that the coin does not slip away. Okay. This question is from the chapter of laws of motion. So let us try to understand this question as, let us say this is a disk, okay? And its angular velocity is omega. Let us say it is moving with the angular velocity of omega, okay? A coin is placed over this disk, on this disk, and the distance of this coin from the center of the disk is given as r. Okay, and mu is the friction between the coin and the disk. The coefficient of friction mu is in between the coin and the disk. So we have to find the maximum angular velocity, means we have to find the value of omega such that the coin does not slip away from this disk. Okay, since now the coin is on the disk, so the friction force which is acting towards the center due to this coin will be equals to mu mg. This friction force will be equals to mu mg, and this will be equals to centripetal force, that is m r omega square. When this friction force is equals to centripetal force to that is acting towards the center, only this is the situation when the coin does not slip away from the disk. Okay, so to make this coin stable on the disk, this friction force must be equal to this centripetal force. Okay, now this cancels out each other. So mu g will be equals to r into omega square. So omega square will be equals to mu g over r. So omega will be equals to under root of mu g over r. So the correct option is option C. Now next question 48. Two conductors have the same resistance at 0 degrees Celsius, but their temperature coefficient of resistance are alpha 1 and alpha 2. The respective temperature coefficient for their series and parallel combinations are. Okay, we have to find the temperature coefficients when these two resistances are at first connected in series, then in parallel. Okay, so let us assume that there are two resistances. This is one, and this is another resistor having resistances, let us say R1 and R2. Okay, their temperature coefficients are given as alpha 1 and alpha 2. Okay, at first let us suppose that they are connected in series. Okay, when they are connected in series, if their resistance are, let us say R, okay, have same resistances na, sorry, if their resistance are R and R, so when they are connected in series, then at that time their equivalent resistance will become 2R. Okay, now if delta T is the change in this resistance R and delta T is the change in this resistance R, so there should be a change of delta T when they are connected in series also. Okay, if delta T is the change in this resistance having coefficient alpha 1 and delta T is the change in the resistance having temperature coefficient alpha 2, then according to logic delta T must be the change in the resistances when they are connected in series also. Okay, so for series we write R equivalent equals to R1 plus R2. Okay, means R equivalent will be 2R, means 2R 1 plus alpha. If delta T is the change, it will be equals to R for this one, 1 plus alpha into delta T plus R. Now for this one, R 1 plus alpha 1, alpha 2 into delta T. Okay. Now solving it, this is alpha equivalent for the series combination. Okay. So 2R 1 plus alpha equivalent into delta T will be equals to this will become R plus R alpha 1 delta T plus R alpha 2 delta T. So this will be equals to R 2R plus alpha 1 plus alpha 2 R delta T. Okay, so and this is equals to 2R 1 plus alpha equivalent into delta T. So now solving, when we solve this, we get alpha equivalent equals to alpha 1 plus alpha 2 over 2. So this is for series combination, means when these two resistances having same resistances R and R, when they are connected in series having temperature coefficient alpha 1 and alpha 2. So when they are connected in series, they are alpha equivalent. Means the temperature coefficient for the series combination is equals to alpha 1 plus alpha 2 over 2. Now when they are connected in parallel, okay, when they are connected in parallel means this is resistor 1 having resistance R, this is another resistor having resistance R. When these two are connected in parallel, so their equivalent will be so we have to find their equivalent temperature coefficient, okay, alpha equivalent. So at this time 1 over R equivalent will be equals to 1 over R1 plus 1 over R2. Okay. So when two resistors having resistance R and R, when they are connected in parallel, at that time R equivalent is equals to what? R1 into R2 over R1 plus R2 means these are same. So R square over 2R. So R equivalent is what? R by 2 na. So putting this value here, so 1 over R equivalent means 1 over R by 2, 1 plus alpha equivalent into delta T equals to 1 over R 1 plus alpha 1 delta T plus 1 over R 1 plus alpha 2 into delta T. Okay. Now solving it, we get 2 over this R cancels. So we get 2 over 1 plus alpha equivalent delta T is equals to 1 over 1 plus alpha 1 delta T plus 1 over 1 plus alpha 2 delta T. Now this 2 over 1 plus alpha equivalent delta T will be equals to 1 plus alpha 2 delta T plus 1 plus alpha 1 delta T over 1 plus alpha 1 delta T into 1 plus alpha 2 delta T. Now it will be equals to 2 1 plus alpha 1 delta T into 1 plus alpha 2 delta T. It will be equals to solving, multiplying this with this and solving it, we get 2 plus alpha 1 plus alpha 2 into delta T into 1 plus alpha equivalent into delta T. Okay. Now we get 2. Now solving these two, we get 1 plus alpha 1 delta T plus alpha 2 delta T plus alpha 1 alpha 2 delta T. Okay. So it will be equals to 2 plus 2 alpha equivalent delta T plus alpha 1 plus alpha 2 into delta T. Okay. Plus alpha equivalent alpha 1 plus alpha 2 into delta T square. Okay. Alpha 1, alpha 2, here also delta T square. Now, neglecting the small terms, we get 2 plus 2 alpha 1 plus alpha 2 into delta T will be equals to 2 plus 2 alpha equivalent delta T plus alpha 1 plus alpha 2 into delta T. So we get alpha 1 plus alpha 2 into delta T will be equals to 2 alpha equivalent into delta T. So now for parallel combination, alpha equivalent will be alpha 1 plus alpha 2 over 2. Okay. So for parallel combination, alpha equivalent will be alpha 1 plus alpha 2 divided by 2. So we see that for both series and parallel, the alpha equivalent are equal to alpha 1 plus alpha 2 divided by 2. So the correct answer is option B. Okay. So the next question is 49. An artillery piece of mass M1 fires a shell of mass M2 horizontally. Instantaneously after the firing, the ratio of kinetic energy of the artillery and that of this shell is. So according to question, there is a mass M1 and this mass fires a shell of mass M2 horizontally. Okay. So we have to find the ratio of the kinetic energy of this artillery and of this shell. Okay, means K1 or K2. Ratio of K1 over K2. Now, using conservation of momentum. Conservation of momentum. Okay. Conservation of momentum. P1 equals to P2 means the momentum of this artillery will be equals to the momentum of this shell. And we know the relation between kinetic energy and momentum is p square over 2m. Since the momentum is same, means ke1 will be equals to e1 square over 2m1 and kinetic energy of shell will be equals to p2 square over 2m2. Since p1 is equals to p2, so kinetic energy basically depends over 1 over m, means inversely proportional to mass. So kinetic energy of artillery over kinetic energy of this shell will be equals to 1 over m1 over 1 over m2, means kinetic energy of 1 to the kinetic energy of 2 will be equals to m2 over m1. Okay. So its correct answer is m2 over m1, means option B is the correct option. Now next question 50. When a metal surface is illuminated by light of wavelength lambda, the stopping potential is 8 volt. When the same surface is illuminated by light of wavelength 3 lambda, the stopping potential is 2 volt. The threshold wavelength of the surface is. So this question is of the photoelectric effect, means this question is from the chapter of dual nature of matter and radiation. Okay, matter and radiation. As we all know, photoelectric effect phenomena when the photons of sufficient frequency intensity having wavelength lambda falls on the surface of the metal, the electrons are ejected from the surface of the metal and these electrons are called photoelectrons. Okay, photoelectrons. So the kinetic energy, maximum kinetic energy in this case will be equals to initial kinetic energy plus work function phi. So this maximum kinetic energy is equals to basically charge of an electron into its voltage equals to initial kinetic energy, means hc over lambda plus this work function. Work function is equals to hc over lambda naught, where lambda naught is the threshold wavelength of the surface, this which we have to calculate. Okay, hc over lambda naught. Okay, now, okay, this is minus. Okay, now we are given with the voltage. Voltage is what? 8 volt. When the wavelength is lambda, the stopping potential is 8 volt. And when the wavelength is 3 lambda, the stopping potential is 2 volt. We have to find lambda naught, okay, threshold wavelength. So 8E will be equals to hc over lambda minus sc over lambda naught. This is equation 1. And When it is 2 volt, means 2E equals to SC over, then the wavelength is 3 lambda minus HC over lambda naught. This is equation second. Now solving them, we get from this 8, SC over lambda naught will be equals to 8, it will be HC over lambda minus 8E. This HC over lambda naught will be equals to SC over lambda minus 8E. Now putting this value of SC over lambda naught in this. Okay, we have to find lambda naught now. Okay, wait. When we find here, from here we find the value of HC over lambda. Okay, from equation 1, HC over lambda will be equals to 8E plus HC over lambda naught. Okay, now put this equation in equation second. So solving 2E equals to 1 over 3, and in place of HC over lambda put 8E plus HC over lambda naught minus HC over lambda naught. Now solve it. It will be equals to 8 by 3E plus HC over 3 lambda naught minus HC over lambda naught. Here 2E. So this 8 by 3E minus 2E equals to HC over lambda naught minus HC over 3 lambda naught. Okay. So it will be equals to 3, 8E minus 6E. It will be equals to 3 lambda naught, means 3 HC minus HC. Okay, this will become 2 over 3 will be equals to 2 HC over 3 lambda naught. This 3 cancels, 2 cancels. So this lambda naught will be equals to HC over E. Okay, now putting the value of H, C and E, we get lambda naught in terms of lambda, 9 lambda. Okay, so the correct answer is lambda naught equals to 9 lambda, that is option C. So the next question is 51. An electron moves through a uniform magnetic field given as B equals to B naught iota cap plus 2 B naught J cap Tesla. At a particular instant of time, the velocity of electron is U equals to 3 iota cap plus 5 J cap meter per second. If the magnetic force acting on the electron is given as 5 E K cap Newton, where E is the charge of electron, then we have to find the value of B naught. So this question is from the chapter of magnetic effects of current and magnetism. Current and magnetism. So this question says that the B is given as this and the initial velocity is given as this. We have to find the value of B naught, okay? As we know that the Lorentz force F is given as Q V cross B, where Q is the charge of electron, V is the velocity and B is the magnetic field. Okay, so force is given as 5 E K cap Newton equals to charge of electron is E and velocity is given as 3 iota cap plus 5 J cap meter per second into cross multiply of B naught iota cap plus 2 B naught J cap. We have to find the value of this B naught, okay? Now simple solving it, 5 E K cap is equals to E. Okay, then I cross I, 0, this I cross J. I cross I is 0, I cross J is K, K cross K is 0, K cross J cross K is iota, and K cross I is J cap, okay? And K cross K is 0, okay? So this I cross I is 0, I cross J is what? K cap. So we get 3 to 6 B naught K cap plus this J cross I. I cross J is K cap. So J cross I is minus of K cap, means minus of 5 B naught K cap. Then plus this J cap cross J cap 0. So we get 5 E K cap is equals to E. 6 minus 5 is what? B naught K cap. This E cancels. So we get 5 is equals to 5 K cap is equals to B naught K cap. So we get B naught is equals to this K cap cancels. So we get B naught is equals to 5 Tesla. Okay. So the value of B naught is 5 Tesla. Now next question 52. A parallel plate capacitor with plate separation 5 mm is charged up by a battery. And it is found that on introducing a dielectric sheet of thickness 2 mm, while keeping the battery connections intact, the capacitor draws 25% more charge from the battery than before. The dielectric constant of the sheet. Okay, and we have to find the value of K. So this question is from the chapter of electrostatics. Okay, now according to this question, there is a capacitor. Its capacitance is C and charge is Q, and it is connected to a voltmeter having potential V. Okay, now when it is a dielectric is introduced in between these capacitor. Let us say this is a dielectric. It is introduced between these capacitor plates and it is connected to the same voltage V. Let us say now its capacitance becomes C1 and this dielectric is of 2 mm thickness. So dielectric is having 2 mm thickness and the parallel plate capacitor, this separation is of 5 mm. Okay. Now as we know that according to question, the new capacitor draws 25% more charge from the battery than before. Let us say at first it is having a charge Q. Now it is this capacitor whose capacitance is C1 is having 25% more capacitance, more charge. It means if initially the charge is Q, now the new charge will be Q dash will be Q plus 25 over 100 into Q, means Q plus 0.25 Q. It means 1.25 Q. So the charge of this capacitance is 1.25 Q. Okay. Now using the equations for capacitance, since we know that charge is equals to capacitance into voltage. Okay, so the charge is what? 1.25 Q equals to capacitance C1 into V of this. Now we are talking about this capacitor, this circuit. So for this, the charge is equals to C into V. C is what? C1 into V. This Q is of initial one to 1.25 Q equals to C into V equals to C1 into V. This V cancels out since the potential is same. So we get 1.25 means 5 by 4 into C equals to C1, and we know the formula for capacitance C is equals to epsilon naught A over D. D is the thickness between the parallel plates. Okay, so this will be equals to 5 by 4 into epsilon naught A over D equals to this C1. This is the value of capacitor or capacitance when there is no dielectric between the parallel plates. Okay, now when dielectric is introduced between the parallel plate capacitor, then its capacitance become epsilon naught A over D minus T plus T by K. Okay, so it's we write in place of C1 epsilon naught A over D thickness between the parallel plates minus T plus T by K. K is the value of dielectric constant. Okay, and now solving it we get epsilon naught A cancels out. So we get 5 by 4 into 1 over D. Distance between the parallel plates capacitor is 5 millimeter is equals to 1 over 5 minus 2 plus 2 over K, where T is the thickness of dielectric, which we have introduced between the parallel plate capacitor. Okay, so solving it, we get 1 by 4 is equals to 1 over 3 plus 2 by K. So it will become 3 plus 2 by K is equals to 4. So now 2 by K is equals to 1. Therefore, K dielectric constant is equals to 2. Okay. So value of K is here 2. Okay. Now next question 53. Equivalent resistance of the following network is. We have to find the resistance of this network. So this question is from the chapter of current electricity. Current electricity. Okay. So electricity. Now we have to solve this network. Okay. Now for this is a plain wire. Okay. For a plain wire, the resistor next to it will be short circuit. So this 6 ohm resistance will be short circuit. 6 ohm is short circuit. Whenever there is a plain wire, so the resistance just parallel to it, near to it and parallel to it becomes short circuit. So 6 ohm becomes short circuit. Now our network becomes as this will be 2 ohm, this will 2 ohm, 2 ohm, 3 ohm, again one resistor having resistance 3 ohm, this is A and this is B. Now these 2 ohm are in parallel. So for parallel we get R equivalent is equals to 2 cross 2 over 2 plus 2. It will be 4 by 4 equals to 1 ohm. So their equivalent resistance is 1 ohm. Okay. Now this 1 ohm and this 2 ohm, these two are in series, means the equivalent of these two will be 3 ohm. Okay. So now the network becomes as 3 ohm, 3 ohm and 3 ohm. These three registers, these are in parallel. Okay. A, B. Now solving this, these three registers we get R equivalent is equals to 3 into 1 by 3 equals to 1 ohm. So the equivalent resistance for this network is equals to 1 ohm. Okay. Now next question 54. A solid circular disc of mass 50 kg rolls along a horizontal floor so that its center of mass has a speed of 0.4 meter per second. The absolute value of work done on the disc to shop it is. We have to find the value of work done. So this question is from the chapter of work, energy and power. Okay. Now, according to this question, there is a solid circular disc. There is a solid circular disc. Its mass is 50 kg. It rolls along a horizontal floor so that its center of mass has a speed of v equals to 0.4 meter per second. We have to find the work done. Okay. Now using work energy theorem. Using work energy theorem, the work done is equals to change in the kinetic energy. Okay, it means the initial kinetic energy is 0. At first it will be at rest. So initial kinetic energy is 0 minus half mv square, its kinetic energy, plus rotational energy, half I omega square. Okay. Now it will be equals to 0 minus half mv square 1 plus k. 1 plus k means how we write it? Half I omega square. Okay. Since I is what? Mr square. So we write k mr square into omega square. Since v is equals to r into omega. So omega will be equals to v over r. So in place of omega square, we write v square over r square. So this r cancels. So for half I omega square, we get 1 by 2 mv square into k. Putting this value of half mv square into k in place of this and taking half mv square common from both, we get change in the kinetic energy is equals to half mv square 1 plus k. Now taking only its magnitude, we get work done is equals to half mv square 1 plus k. And for a rolling disk, the value of k is 1 by 2. Since the moment of inertia for a rolling disk is half I equals to half mr square, so the value of k is half. So we get work done is equals to half mv square 1 plus k. Now putting the value of all the parameters, half into mass is 50 kg, velocity is 0.4 meter per second na. So 0.4 whole square into 1 plus k, k is 1 by 2. Now 2, 25, 50, so it will be equals to 25 into 0.16 into 3 by 2. Now solving it, we get 2, 8 is 16, so 25 into 8 is 24, 2.4. We get 6 joule. Okay, so work done will be 6 joule. Now next question 55. A body starts falling freely from height h, hits an inclined plane in its path at a height h. As a result of this perfectly elastic impact, the direction of the velocity of the body becomes horizontal. The value of h over h for which the body will take the maximum time to reach the ground. So this question is from the chapter of kinematics. Now, according to this question, a body, let us say this is a body A, okay? It falls freely from a height of h and hits an inclined plane, okay? Let us say this is an inclined plane and this is a body A. It is falling from a height h. Let us say this height is h, okay? Let us say this whole height is capital H and it hits an inclined plane in its path at height h, okay? It means it hits this inclined plane and the distance between this is small h. So the distance between, let us say this is point is o, so the distance AO, it will be equals to capital H minus small h, okay? And the direction of the velocity of body becomes horizontal, okay? When the body hits this inclined plane, after hitting this, its direction becomes horizontal, okay? We have to find the value of h over h. So for the maximum time to reach the ground, the total time of flight is from the projectile motion, total time of flight is equals to t. So t will be equals to under root 2 hg plus under root 2 h minus h over g. Under root 2 hg for this distance, under root 2 hg plus under root 2 hg. H minus h is for this distance, okay? Now solving it for the maximum time. For maximum time means dt over dh is equals to 0 for maximum time. So differentiating this with respect to h, we get under root 2 over g minus 1 over 2 under root h minus h plus 1 over 2 under root h is equals to 0. Now this under root h minus h will be equals to under root of h. So h squaring both sides, h will be equals to h by 2, or we can say that h over h is equals to 2. So the value of capital H over small h is equals to 2. Okay, now next question 56. Two waves of intensity ratio 1:9 cross each other at a point. The resultant intensities at the point when A waves are incoherent and B is waves are coherent is I2 and differ in phase by 60 degree. We have to find the ratio of I1 over I2, that is 10 over x, and we have to find the value of x. Okay, so this question is from the chapter of wave optics. Now we know that the simple formula for incoherent waves, when two waves those are incoherent, the resultant intensity is defined as I1 is equals to IA plus IB, where A and B, let us say these are two waves having intensities IA and IB, and these two waves are incoherent. Incoherent means the phase difference between them is not constant. So these are incoherent waves. So their resultant waves, as given in this question, I1. So their resultant wave I1 means when they combine, so their resultant wave I1 is equals to IA plus IB. It means it is equals to I1 will be equals to IA, and since the two waves are in the intensity ratio of 1:9, means if IA is having an intensity of I naught, then the IB is having an intensity ratio of 9 I naught. Okay, so IA plus IB means I naught plus 9 I naught. It will be equals to 10 I naught. So I1 will be equals to 10 I naught. Okay, this is, let us say, equation number 1. Now for the coherent waves, the formula for coherent waves mean there is a constant phase difference between them. Okay, so their resultant I2, let us say it will be equals to IA plus IB plus 2 under root of IA into IB into cos theta, and in this question the theta is given as 60 degree. Okay, so cos theta we have to write cos 60 degree. Now solving it we get I naught plus 9 I naught plus 2 under root of I naught into 9 I naught into cos 60 is 1 by 2. So solving it we get I naught plus 9 I naught, 10 I naught plus 2 cancels under root of 9 I naught square. Okay, so we get 10 I naught plus 3 I naught. It will be equals to 13 I naught. So I2 will be equals to 13 I naught. This is equation second. Now the ratio of I1 over I2. So I1 over I2, it will be equals to I1 is what? 10 I naught. So 10 I naught over 13 I naught. It will be equals to 10 over 13, and comparing it with the given equation in the question, 10 over x. So the value of x is 13. This is our final answer. Now next question 57. A small square loop of wire of side L is placed inside a square loop of wire of side L, where capital L is equals to small l square. The loops are coplanar and their centers coincide. The value of the mutual inductance of the system is given by this. We have to find the value of x. So this question is from the chapter of electromagnetic induction and alternating current. Electromagnetic induction and alternating currents. Okay. Now from this, there is a square loop there is a big square loop. Inside this square loop, a small square loop is placed. Its side is small l and its side is capital L, where given as capital L is equals to small l square. Okay, we have to find the value of mutual inductance. So to find mutual inductance, that is M is equals to phi over I. Okay, phi over I. So at first we have to find the value of phi. So for finding the value of phi, we have to find the magnetic field B at the center of the square loop into I. Since the formula for phi plus equals to B into I, then M will be equals to phi over I. So for this, at first we have to find the value of B, that is magnetic field at the center. So if we find this magnetic field due to one side of the loop and multiply it with 4, we get the magnetic field at the center due to all the sides, means due to the whole square. So this phi will be equals to 4 into magnetic field due to one side. Okay, so this magnetic field due to one side, it will be mu naught over 4 pi into I over R into we have to write like this. Let us say for this we will find the magnetic field from here using such type of diagram. So magnetic field due to side this and due to side this at the center will be, to find this we will draw it as like this. Let us say this is the center O and this is one of the side. Let us say this is A, B and C, D. Suppose we have to find the magnetic field at point O due to side A, B. So for this, the equation is given as P is equals to mu naught over 4 pi I over R, where R is this distance, the center O from this side. Okay, and let us say it is making an angle alpha 1 here and alpha 2 here. So sine alpha 1 plus sine alpha 2. And since we know that each side of the square corner is making an angle of 90 degree, this is a perpendicular bisector and perpendicular bisector cuts in equal angle. So this angle will be 45 degree and this angle will be also 45 degree. So here alpha 1 and alpha 2 both are 45 degree. So here we can write sine alpha 1 means sine 45 degree plus sine alpha 2 means sine 45 degree. So it will be equals to mu naught over 4 pi into I over R. Now, this small loop is inside the small square is inside the bigger square, having a side L where this L is equals to small l square. So for this we write R as L by 2. L by 2 means this is whole L. So for this we write L by 2. So L by 2 into sine 45 degree plus sine 45 degree into this side L square. L square means since this is a small loop na, and this capital L equals to small l square. So we write L square. So solving this we get phi will be equals to 2 root 2 mu naught I over pi L into L square, putting the value of sine 45, 1 by root 2, 1 by root 2, and solving it, we get phi is equals to 2 root 2 mu naught I over pi L into L square. Now, the mutual inductance M will be equals to phi over I into 4, okay, into 4 also. So, it will be equals to 2 root 2 mu naught I over pi L into L square divided by I, means this I cancels. So we get 2 root 2 mu naught over pi. Since this capital L is equals to small l square, so this capital L is small l square cancels out. Okay, so we get m will be equals to 2 root 2 mu naught over 4 pi. Now we know that mu naught is equals to 4 pi into 10 to the power minus 7. Putting this value of mu naught, we get mutual inductance m will be equals to 2 root 2 into 4 pi into 10 to the power minus 7 over pi. This pi cancels. So we get m will be equals to 8 root 2 into 10 to the power minus 7 Henry. So m will be equals to 64 into 2 into 10 to the power minus 7 Henry. So m will be equals to 6 to the 12 carry 1. Sorry, 4 to the 8 and 6 to 12 means 128 into 10 to the power minus 7 Henry. Okay. Now comparing it with the given equation, under root x into 10 to the power minus 7. Comparing it with under root x into 10 to the power minus 7, we get x is equals to 128. This is our final answer. Now next question, 58. The depth below the surface of sea to which a rubber ball to be taken so as to decrease its volume by 0.02% is dash meter. We have to find the depth. Okay, we are given with the density of water and bulk modulus. So this question is directly from the topic of bulk modulus, means from the chapter of properties of solids and liquid. At first, we should know what is bulk modulus. Okay, so bulk modulus means it measures how incompressible a liquid is. Modulus measures how incompressible incompressible the liquid is. Sorry, the solid is. Okay, now its formula is given as bulk modulus K is equals to minus delta P, means change in pressure over change in volume over original volume. Okay, so what we have to find? We have to find the depth below the surface of the sea to which a rubber ball to be taken so as to decrease its volume. The volume is decreasing by 0.02%. Okay, means we have to find the value of H. We have to find depth. Okay, now this delta P will be equals to what? Minus of K bulk modulus into change in volume over original volume. So this change in pressure we write in terms of density and height as rho GH. Change in pressure will be equals to rho GH equals to minus of K bulk modulus into delta V over V. So rho is given as 10 to the power 3. Gravity is 10. Height, this we have to find the depth, equals to bulk modulus. Bulk modulus is given as 9 into 10 to the power 8 Newton. 9 into 10 to the power 8 Newton into delta V. The volume is changing by an amount of 0.02% over original volume, means we write 0.02 and it is decreasing. The volume is decreasing. So here we write minus sign over 100. Okay. Now solving it, this minus minus cancels. 10 to the power 4 into h will be equals to 9 into 10 to the power 8 minus 2 into 0.02. So h will be equals to 9 into 10 to the power 6 over 10 to the power 4 into 0.02. So solving it, we get h is equals to 9 to the 18, means 18 meter. So the depth is 18 meter. Okay. Now next question, 59. A particle performs simple harmonic motion with amplitude A. Its speed is increased to 3 times at an instant when its displacement is 2a by 3. The new amplitude of the motion is na over 3. We have to find this value of A. So this question is from the chapter of oscillations and waves. Oscillations and waves. Students, such type of questions are being repeatedly asked in 2024 papers. Okay, we have already seen a series of pattern of asking such type of question in these 2024 exam, JEE exam. So you should practice these type of question as well for the next April exams also. Okay. So according to this, if here the amplitude is 2a by 3, so we have to find, let us say this is amplitude A, and according to question, a particle is performing simple harmonic motion having an amplitude A, and its speed is increased 3 times when its displacement is 2a by 3. Let us say initially its speed is v, and when its speed changes to 3v, then its displacement become 2a by 3. Okay, so we have to find the new amplitude of the motion when the speed becomes 3v. Okay, it means according to question, when the amplitude is 2a by 3, at that time the velocity is v. By anyhow, the velocity now changes to 3v. Okay, so at that time the amplitude becomes na by 3. So we have to find this value of n. Okay, now for this, we know that the velocity vector for such type of question is given as omega, angular speed, into a square minus x square. Here x is what? 2a by 3. Now putting the value, we get v is equals to omega under root of a square minus 2a over 3 whole square. Okay, so solving it, we get omega under root 6a, no, sorry, 9a square, 9a square minus 4a square over 9. So we get omega under root of 5a square over 9. So means the value of v is equals to under root of 5 omega a over 3. Okay, now let us say the new amplitude is a dash. Okay, new amplitude is a dash. So for this new amplitude, the velocity v dash becomes as 3v. Now, according to question, the velocity becomes 3v. So for this 3v velocity, let us say the amplitude is a dash. So v dash means 3v is equals to what? Omega under root of this a square minus x square. Still, this x is 2a by 3. Okay, so this v dash is 3v is equals to omega under root of a square minus 2a over 3 square. Okay, so solving it, and this is equals to what? A dash na. So solving it, we get a dash is equals to 7a by 3. This is our final answer. Okay, now next question 60. The mass defect in a particular reaction is 0.4 gram. The amount of energy liberated is n into 10 to the power 7 kilowatt hour. The where n is, we have to find the value of n. So this question is from the chapter of atomic and nuclei. Atomic and nuclei. Okay. Since we know that the energy is given as delta mc square, and we are given delta m, we know the value of c, that is the speed of light. We have to find the value of energy liberated in terms of n into 10 to the power 7. Okay, so energy will be equals to delta m is what? 0.4 gram means 0.4 into 10 to the power minus 3 into 3 into 10 to the power 8 whole square. So solving it, we get 3600 into 10 to the power 7 kilowatt second. Since the speed is in terms of meter per second, and we have to find answer in terms of kilowatt hour, so we have to convert this second into hour. So E will be equals to 3600 into 10 to the power 7 over 3600 in terms of kilowatt hour, since 1 hour is equals to 3600 second. Okay, now solving it, we get 3600 3600 cancels, So energy E will be equals to 1 into 10 to the power 7 kilowatt hour. So the value of N here is what? N is 1. This is our final answer.